All right, the learning target that we're talking about right now is transforming quadratics between forms. And the forms that we're talking about are standard form, which is our basic y equals ax squared plus bx plus c. Vertex form, which is where we have the x minus h quantity squared plus k, where the h and the k are the vertex. And there's a number, it could be a number out in front here. And intercept form, which is x minus a and x minus b, where the a and the b represent the x intercepts. I, sometimes think about that as in factored form. All right? So we want to be able to move from one form to the other form because it might be helpful in learning about the function, in finding something important about it. So let's see how we're going to do that. Converting to standard form. All right, so here is an equation that is in vertex form, and I want to make it be standard. Well, basically what I'm going to have to do is I'm going to have to do some FOIL method, or the distributive property. And so what I'm going to first do is figure out what x minus 1 quantity squared is. And because I've done a lot of those before, I know that's going to be x squared minus 2x plus 1 plus 9. And then as I put this back together, I can distribute the 3. Well, I can distribute the 3. Well, anyway, that'll be 3x squared minus 6x plus 3 plus 9, and then by combining some like terms, I'll get 3x squared minus 6x plus 12. And now I've successfully taken that from vertex form to standard form. All right? The same thing if I was looking at an equation in intercept form right here, I need to just do the distributive property right here, the extended distributive property. I need to go x times x and x times 7, negative 3 times x, negative 3 times 7, and that will give me x squared plus 7x minus 3x minus 21. And then it's just a matter of combining like terms and distributing. So let's combine first x squared plus 4x minus 21. And that's going to be negative 2x squared minus 8x plus 42. All right? And so we've now converted from intercept form to standard form. So getting things to standard form is usually going to involve FOIL method, multiplying two binomials together, something of that sort. Now, changing to vertex form, this is going to involve the old thing called completing the square. All right? So we're going to have to complete the square here. So how do we complete the square? Well, we get the x squared minus 4x, and I want to put a number in here that will make this a perfect trinomial square. Well, in order to do that, I had to get rid of this 11 halves, didn't I? I had to take it to the other side, and remember, whatever we put here, we're going to have to add over there also. So what number can we put here? Well, take your b value, cut it in half. See, what's half of negative 4? Well, it's negative 2. Then square it. Oh, well, that's going to be positive 4. So I need to add 4 to each side. All right? And now I'll have x squared. Oh, let's not do that. Let's go back a step here. See if it'll let me go back a step. Yeah. And let's actually factor this. That's going to be x minus 2 quantity squared equals, let's see, a negative 11 halves is really negative 5.5, right? So if we negative 5.5 plus 4, that's going to be negative 1.5, or negative 3 halves. And now, if I bring that back over to that side, I'll have x minus 2 quantity squared plus 3 halves. There's my a value of 1. My vertex is at 2 3 halves, and I've got this in vertex form. All right? So yes, we had a nasty little fraction there, but that's okay. Now to do this one, we've got a negative 3 in front of the x squared. That's going to complicate things just a smidge, but we can handle it. First thing we're going to do is get the negative 3x minus 6x by itself here, which means we've got to get the negative 4 gone. So we'll put that over there. Then what we need to do is we need to factor out this negative 3. All right, when I factor out the negative 3, what am I left with? X squared plus 2x. Now I can put a number in here that makes this a perfect trinomial square. So take half of 2, that's 1, and square it, that's 1. Okay? Now be careful, you can't put a 1 here because you didn't really add 1. It's negative 3 times 1, so really it's negative 3 that you got to put over here. All right? And then we can factor, that's going to be x plus 1 quantity squared equals, what's 4 plus negative 3? Well, that's 1. So now I can bring the 1 back over here, minus 1. There's my vertex form. Vertex is negative 1, negative 1. All right? So completing the square, that helps you go from, it helps you get to vertex form. And finally, changing to intercept form. Well, the word of the day for this is factoring. Yes, we just need to factor. So here's a trinomial. We could take a 2 out of there, I think. Can't you take a 2 out of 6, 10, and 4? I believe you can. So that'd be 3x squared plus 5x minus 2. Well, now I can probably factor. I'll bet you that this factors. The way I do this is I say 3 times negative 2, that's 6. What factors of 6 add up, subtract to give me 5? Well, it's 1 and 6. So watch what I do here. This is a little crazy. You can explain this to, I can explain this to you later if you really need it. I'm using 1 and 6. I know that this is going to be positive, this is going to be negative, and I'll bet you that there's a GCF we can take out of here. X plus 2. There is my intercept form. My intercepts are negative 2 and positive 1/3. All right. Now, what about this one here? Well, the first thing you could do here is you could pull out a greatest common factor, and that would leave you with x squared minus 4. If I divide both of these by 5, right? Oh, this is a difference of squares, isn't it? And that factors into x minus 2 times x plus 2. There's my intercept form. All right, so it just takes a little practice, but you can convert to any form you want. Completing the square may be used, factoring may be used, or just plain old FOIL method may be used. All right, good luck.